Perfect. Well, welcome everyone. Thank you for joining us today. We're just going to do a quick introduction explaining who we are and what activity we'll be doing today. So hello, I am Sonia. I am a second-year student majoring in biohealth sciences with a minor in chemistry.
Hi, I am Grace. I am a third year majoring in biochemistry and molecular biology with minors in chemistry and writing. We are both students from OSU, and we are in community service officers for Sigma Delta Omega, an academic science sorority organization on campus.
I'm going to share my screen really quick. All right. So our philanthropy or charity is associated with K through 12 STEM education. So we were very, very excited when we got the opportunity to help out with this STEM webinar series. And hopefully we were able to help all of you interested in going into a science-related field and learn more about chemistry through a fun experiment we have planned. And just quick note before we start, feel free to put any questions you have in the chat or the Q&A function. We'd love to answer any questions you have, whether it's about the experiment or life as an OSU student. So anything you have in mind.
Great, so as you already know, today we will be making DIY lava lamps. Woohoo! So along with this experiment, we will learn about the chemical processes and molecular reactions happening within the lava lamp, highlighting topics like density and polarity. We have provided an optional fill-in-the-blank worksheet for students to complete in case you want to refer back to the information covered in our session today. The materials you will need for this experiment are a flask or an empty water bottle, Alka-Seltzer, food coloring, any color will do, and some vegetable oil and water.
Let's get started. Okay, so we will now start our experiment. The first thing you're going to want to do is fill up your flask or empty water bottle most of the way with vegetable oil, leaving about 1.5 inches from the top. And since everyone is going to be using a different container, I'm assuming, the setup might look a little different for you. Go ahead and do that.
Trying to be so careful not to spill anything.
How much oil is that? It depends on your container. So Grace and I are using 2 different containers, but we're filling it most of the way up, leaving a little bit of room at the top.
So I'm just using a standard water bottle, and I'm using a measuring cup to pour out my oil. And so I think I've put in about 2 cups so far, and I'm planning on to put like another half a cup in. So if you're using a water bottle, those should be good measurements.
Yeah, mine's about 2 cups as well on mine.
Great. Okay, so now on to the next step. So once you've done that, fill up the rest of the container with water. So the water will sink to the bottom under the oil, and it will look like clear blobs surrounded by the oil. The water sinks to the bottom because it is more dense than oil, and the water and oil are not mixing together because oil is nonpolar and water is polar. And we will talk more about this density and polarity in a little bit. So now we'll unshare again.
So we have one question as you are doing that. Could you use fractionated coconut oil?
Ooh, I've actually heard of people using coconut oil or baby oil, so you can definitely experiment with that. I think the results might come out slightly different, but I think it'll be interesting to experiment with that.
Yeah, maybe you can have some sort of comparison going on.
And then there's another question about sending the video and a how-to with instructions. This video that we're creating right now is going to be posted on our website where you saw this link, and it'll be posted within a week. So this will come up with the instructions and the ingredients and materials.
Okay, so just for quick reference, these are my clear blobs at the bottom of my container in case you guys are wondering what it looks like and you want to compare.
All right, so next we are going to be adding a few drops of whatever color food coloring you would like. All scientists make hypotheses or guesses about what they think will happen. When we put this food coloring in, do you know if it will mix with the oil, with the water, or will it mix with something else? And once you have an idea in mind, we're going to add in the food coloring. I think I'll start off with maybe 5 drops and see how that goes.
It looks good.
Yeah, so the food coloring is water-based, if you couldn't tell already. So since it's water-based, it's going to sink to the bottom, just like the water we added in earlier. And you can shake it around a little bit so that it mixes a little better.
All right, so now we're going to move on to the fun part. So now what you're going to do is open up your Alka-Seltzer container and take out 1 tablet. Before we use it, we're going to make another hypothesis about what will happen when we drop the Alka-Seltzer into the container. So what do you think will happen? Will it react with the oil in the water? Will it be a big reaction? Do you think anything will happen? So keep that in mind before you do this. Now what we're going to do is we're going to break the Alka-Seltzer into small pieces. And then we're going to drop these small pieces into the flask one at a time.
You watch your lava lamp in action. So as the reaction slows down, it'll start slowing down eventually. You can use another Alka-Seltzer tablet and just crush those up into little pieces and then put them back in your experiment.
All right, so this was the whole reaction, but now we're going to go over some of the fundamental principles of what makes this reaction possible. So there are 3 main principles, and they are density, polarity, and the reaction chemistry.
Here's another close-up. All right, so as we mentioned earlier, when we add water to vegetable oil, the water sinks to the bottom of the flask because it is denser than oil. So you might be asking, what is density? Density is defined as the mass of a substance divided by the volume, which gives you the equation that's here on the slide, Q equals M divided by V, so mass divided by volume. And since the water is heavier than oil, because the water molecules are more tightly packed together than the oil. So it's going to be the image on the right here. And that means the water will sink if placed in oil because water is more dense than oil. However, density is affected by temperature, and when water is heated, it will become less dense. So that would be kind of fun to experiment maybe in the future with hot water or warm water. And in store-bought lava lamps, they use more hazardous materials instead of water and oil. And like our experiment, the denser liquid will always sink to the bottom. And since density is affected by temperature, the light in the lava lamp acts as a heat source, heating up dense liquid until it expands and actually becomes less dense. So when it becomes less dense, then remember it's going to start rising to the top. Away from the heat source. And when it moves away from the light at the bottom, right here, you can imagine, it cools down. So eventually it becomes dense again and will sink to the bottom. and then the process will start all over again, which is kind of cool to think about in real lava lamps.
Okay, so next topic is polarity. So this is a very important topic in chemistry. It influences a lot of interactions that you'll see. So as you may know, all atoms have base particles called protons, neutrons, and electrons. Protons are positively charged, neutrons have no charge, and electrons have a negative charge. So some of these electrons want more than others. Some of these atoms want electrons more than others. And in this case, since the water is made up of one oxygen atom and two hydrogen atoms, oxygen wants those electrons from hydrogen. And then this creates what we call something called a dipole, which is an uneven sharing of those electrons. And then that creates polarity. And then polarity is defined as the uneven charge distribution between these two atoms. So as you can see here in our slide, we have our penguin and our polar bear, and this represents our water molecule and the unequal sharing of electrons. The polar bear really, really wants those electrons, and the penguin is giving it to them. And Sonia will explain that some more in the next slide.
Yeah, so the penguin represents the hydrogen, and the ice cream represents the electrons, and the polar bear represents the oxygen. So since the polar bear is stronger and bigger, it is able to pull the electrons, or the ice cream in this case, towards itself. And the penguin, or the hydrogen, is much weaker than the oxygen, so it's not able to hold on to any electrons as strongly. And as a result, there's an unequal sharing of electrons amongst the polar bear and the penguin. And remember that electrons are negatively charged.
So this means that the oxygen will have a more negative charge than the hydrogen atoms. The ends of the water molecule with the two hydrogen atoms are positively charged, and the other end with oxygen is negatively charged. So this goes back to the dipole that we're talking about. This is called a dipole moment. So just like in a magnet with north poles are attracted to south poles, or in batteries where the negative poles attract to the positive pole, the positive end of the water molecule will connect with the negative end of the other molecules. So this means that the water, the positive hydrogen atoms on the one molecule are attracted to the negative oxygen atoms on another molecule. And this connection between water molecules forms a hydrogen bond, as shown as the picture on the right. So you can see that positively charged hydrogen is attracted to the negatively charged oxygen.
And in contrast, oil molecules are nonpolar, meaning that they don't have any positive or negative charges. Oil molecules are mostly made up of carbon, and all the carbon atoms want to share the electrons equally. So that means you won't have any positive and negative charges again. And since oil is nonpolar and water is polar, not polar, oil and water cannot be attracted to each other. So in this scenario, we're going to think of the carbon atoms as these two squirrels on the right. And since the two squirrels are the same size and they have the same strength, the squirrels, or the carbon molecules, will share the electrons equally, unlike the polar bear and the penguin.
So this goes back to the water and oil. Polar molecules will only mix with other polar molecules, and non-polar molecules will only mix with other non-polar molecules. So you can think of it as like dissolves like. So if you put something polar in water and mix it up, then it will dissolve. So this is why the oil and the water cannot mix. Like our experiment, real lava lamps use a polar and a non-polar liquid. In store-bought lava lamps, however, the densities of the liquid are much closer together than vegetable oil and water.
And then going into the reaction itself, you may be wondering, what does the Alka-Seltzer do? So the Alka-Seltzer is involved with the reaction portion of the experiment. The Alka-Seltzer reacts with the water to produce carbon dioxide bubbles. And these bubbles stick to the water droplets. So the combination of the water and the carbon dioxide bubbles is less dense than the oil. So less dense, if it's less dense than the oil, then it's going to rise to the top. And that's what makes this like bubble formation form within the lava lamps.
So when the bubbles actually reach the top of the flask or the container, they pop and the carbon dioxide is then released into the air. And this allows the dense water droplets to sink back down to the bottom of the flask. Like you can see here, these bubbles are rising and popping and the water is falling back down to the bottom.
All right. Now we're going to be going into some notable women in chemistry. So the first woman in chemistry that we will discuss is Ruth Erica Benesch. She's a famous female chemist that worked for Columbia University, and she used chemistry to figure out how hemoglobin, which is a component of blood, is responsible for the release and transportation of oxygen around the body. So very important.
Yeah, so another cool one, next woman that we're going to discuss is Irene Jolie Curie. She was the daughter of Marie Curie, another famous scientist who had won 2 Nobel Prizes for her work in chemistry and physics. Most people only win one, so this is a huge accomplishment. And Irene discovered artificial radioactivity and developed many precision laboratory techniques required for radiochemical research. So just like her mom, she did a lot of research with radioactivity.
And we were truly amazed by both of these women's achievements, and we're only touching on a small fraction of women who are a part of chemistry and women in science.
So if you enjoyed this experiment, you might be interested in careers that use chemistry. You may want to be a research scientist when you grow up. Research scientists design and conduct different experiments, usually in a laboratory setting. So think of like microscopes and pipettes, all those cool things. And there are many types of research scientists. Some may do experiments with different polarities to find a cure for cancer or learn more about an unknown disease. So right now, many research scientists are working to create a vaccine for the coronavirus.
You may also be interested in becoming a pharmacologist. Pharmacologists are people who develop new medications for people to feel better faster. So they can help in finding a cure for allergies or a cure for cancer, so different cures for different treatments for different diseases. And some pharmacologists are working on treatments for the coronavirus right now.
So that's all we have today, and we would really like to thank you all for joining us, and also thank you to Emily for setting this all up.
Yeah, we had a lot of fun. We hope you had fun as well. And you can continue doing this experiment. It's really fun if you continue adding Alka-Seltzer. It'll just kind of continue to bubble up and be a lava lamp.
Yeah, so if you all can feel free to leave any questions for us in the Q&A function or in the chat, and we'd be happy to answer any of your questions that you have.
I'll give one as people are thinking and typing them in. What is your favorite thing about being an OSU student?
Ooh, that's a good question. I'd have to say I really like the small town environment and the camaraderie amongst the students, because I feel like you do become really close to a lot of people, in especially your major or just in Corvallis. Corvallis has a very homey feel to it. So I think the environment that I'm in is one of my favorite parts about being an OSU student. And of course, learning about biochem.
I think I would say getting to learn more about science. I was always interested in science in middle school and high school. And I think high school was when I really decided that science is something that I want to do for the rest of my life. So getting to explore more in depth about science and chemistry in particular, I think is very interesting. And at OSU, it's nice to be surrounded by like-minded individuals who are also interested in science, but also get to know people who are maybe in liberal arts or in different majors than you, which is nice about the university setting for sure.
Thanks. Ethan says, thank you so much for teaching us this cool experiment.
Oh,
And then we have one more question. What do you like about chemistry?
this is another good question. My big thing is always like one of the reasons why I love biochemistry so much is I love learning about like what is life and why it's so cool. And so I really like learning about the fundamentals of what makes life possible. And you get to learn so much about that in chemistry. I mean, that's not all that chemistry is, but I love learning about like why does this specific reaction happen this way? It's like, oh, because like these two molecules can interact with each other, and it's because of their properties that makes it possible. So things like that is why I love chemistry so much.
I'd have to agree. I'm very interested in medicine also and helping other people. So like the creation of medications and treatments, I think is very interesting to me. And finding different treatments involves a lot of chemistry and use of even like daily things that we use every day that we kind of forget about, and we can use those to make different treatments, which I think is super cool, just to help people.
Excellent. So I think those are all the questions that we have in. Thank you so much to both of you, Grace and Sonia, for joining us. And we will be doing more STEM activities, hopefully with Grace and Sonia, later this term. But our next one is going to be next Tuesday. So you can check the website for that. Any parting words from you two?
Thank you for joining us today. We had a lot of fun.
Yes, we had tons of fun. Hopefully we'll get to see you again in the future.